Welcome to another series of Chemistry Just Got Easier with our tutors. In today's class, we are going to be talking about rules in determining oxidation number. Because I once created a content on how to calculate oxidation number, and some people chatted me up and said, how did I do it? So I have to take this content to actually explain the rules in determining oxidation number. And in the next class, we are going to do some examples in calculating oxidation number. Now, let's look at what we have on the board. The first rule states that elements in their pure form have oxidation number of 0. For example, what this simply means is that, for example, when you have O2, this O2 does not carry a charge. The oxidation number of this is what? 0. When you have Na, this does not carry a charge. This is 0. H, this is what? 0. This is what this simply means. Then number 2, you have oxidation numbers of monoatomic ions is equals to the ion charge. For example, you have O2 minus. The oxidation number of O2 minus is going to be -2. It's not going to be 0 because it is an ion. So the oxidation number is going to be equal to the charge of the ion. Cl minus is going to be -1. Na plus is going to be +1. Okay? And then we have oxidation number of group 1 elements are +1 in compounds. For example, when you have your lithium, your sodium, your potassium, these are the group 1 elements and they are +1 in compounds. Let's say example. Example when you have NaCl. NaCl is sodium chloride. And let me quickly calculate the oxidation number of sodium, and I'm going to use the rules here. For example, let me go to rule 7. Permits me to go to rule 7. The rule 7 states that the sum of all oxidation number in a neutral compound is equals to 0. That is, in a neutral compound, this is a neutral compound. So the sum, when you add up all the oxidation number, you should have 0. Now, chlorine has an oxidation number, a charge of -1. So let's assume we don't know the oxidation number of sodium. We want to calculate it. So let's say sodium plus, remember we said sum, and chlorine has oxidation number or charge of -1 is equals to 0. Na minus 1 is equals to 0. Add 1 to both sides. So Na minus 1 plus 1 is equals to 0 plus 1. Na is equals to +1. So you can see the oxidation number of group 1 metals in compounds are what? +1, and we have been able to prove that. Let's move on to the next rule. The next one states that oxidation numbers of group 2 metals are +2 in compounds. For example, we have beryllium, we have magnesium. Let's see magnesium. For example, let's see another one. Let's try to calculate the oxidation number of magnesium in magnesium chloride. Now in magnesium chloride, MgCl2, so remember we said the sum of all oxidation number in a neutral compound is 0. When you add everything up, you should have 0. So let's take this as Mg, we don't know, plus. Now the oxidation number of chlorine, or the charge of chlorine, is -1. But we have 2 atoms of chlorine, that is -1 times 2 is equals to 0. So we have Mg minus 1 times 2 will give you -2 is equals to 0. Mg, it will be equals to what? +2. So we have also been able to prove that the oxidation numbers of group 2 metals are +2 in compounds. Then we have hydrogen is usually +1, but it is -1 in metallic hydride. Meaning that hydrogen, the oxidation number is always what? +1. The charge is always +1. But when you have metallic hydride, example of metallic hydride is sodium hydride, NaH. Now let's try to calculate the oxidation number of hydrogen in this metallic hydride. As you know, it is a neutral compound. The sum will be equals to 0. Now, sodium has a charge of +1, so that is +1. Let's assume we don't know the charge of hydrogen. So plus x for hydrogen is equals to 0, +1, subtract 1 from both sides, plus x is equals to 0 minus 1. This cancel out, you have x is equals to -1. Remember, x is represented by what? Is representing hydrogen. So the oxidation number of hydrogen in metallic hydride is what? -1, which we have been able to prove that. Now let's move on to the next rule. The next rule states that oxygen is usually -2, but -1 in peroxide, like hydrogen peroxide, and +2 in OF2. Let's see what we have here. In hydrogen peroxide, remember we said the oxidation number of hydrogen is always what? +1. So let's see. Let's assume we don't know that of oxygen, and this is a neutral compound, that is, the sum will be equals to 0. So we have +1 times 2. Why is +1? Because hydrogen is always +1, except in metallic hydride, and this is not a metallic hydride. Times 2 because we have 2 atoms of hydrogen. Now, plus oxygen, let's take X for oxygen, unknown. And we have 2 atoms of